Lesson 5.9. Do these functions produce the same output for every non-negative integer inputs? Make a table for each rules. So, do these two functions produces the same output for every non-negative integer input? So we only have to think about 0, 1, 2, 3, 4, 5. Those nice, beautiful numbers. We don't have to worry about any fractions or anything. So if we plug in 0, what would happen, right? If we plug in 1, what would happen? If we plug in 2 or 3 or 4 or 5 or 6, do that and make a table, and then do that for F machine and G machine to see if those two functions produce the same output, right? So G is when the input is 0, the output is negative 2/3. So you should have two tables like that. You know, this is for F machine and this is for G machine, and then you put 0, 1, 2, and you should have the same thing on this one. And this is f of x, and this is g of x, right? This is the x, right? And then compare find out the output for each and compare it, and to see if it comes out the same. Okay, that's pretty easy. Number 9, Dana's parents start saving money for college education, and that's what, if you become a parent, that's what you want to do. Start doing it, and I'm doing it for my kids, so that I don't really have to worry about it when time comes, right? So they deposit $5,000 in a fund. Wow, they're rich. That earns 10% interest at the end of the year. Write the recursive rule that describes how the amount of money increases over time. How much money will Dana's parents have after 5 years? So I'll help you get started. So you get x, shouldn't be x, input and output. You know, bank is like a machine, right? So this is like a bank machine. Let's say bank. If you put $5,000, oh, that's awful. Sorry. If you put $5,000, then it gives you 10% of it. So 10% of 5,000 is 500, right? So it gives you plus 10%, which means you multiply by 0.1. So that means, right? So you get 5,500. This is really good bank. You're not gonna see these things out there anywhere recently in this economy. But anyways, if you put $5,000, you get $5,500. And then the next year, the following year, you got $5,500. So you're gonna put that in the bank. So you're gonna put this in the bank. So the second year, you're gonna put $5,500. Oops. In there. So 10% of it, so it's 550 times 0.1 is $550. So you're gonna add to it, so you get $6,050. So that's what you get for the second year, and so on and so forth. The following year, you're gonna put this in here in the bank, and you get something comes out, right? So how much money, the question is, that will Dana's parents have after 3 years? So this is the first year, second year, and the third year, you're gonna put this money. So this will be the input right here, and then find that out what you get for that. Okay. Number 11, Anna earns money by raking leaves. She buys a rake that cost $20. So obviously she has to buy something first. For each lawn she rakes, she earns $6. Make a table using the number of lawns as the input. the amount of money she makes is the output. Calculates how much money Anna earns when she rakes 0 to 5 lawns. Okay. So that's the input, and that's the out. You know, if she doesn't rake any lawn, then how much is she making? She's not making any money. However, she already spent $20, so it's negative 20, right? And then if you go 1, 2, 3, 4, 5, and then if she rakes one lawn, then she's got $6, but she lost $20 already, so it should be negative 14, right? It's just 6 minus 20. So just do it. Keep going. So that's A. B is complete the table for it first, and then find out the rules between these two and these outputs, consecutive outputs, and also the pattern between in and out. Okay, that's what you do for B. And C, you're gonna apply that. Anna wants to buy video games that cost $54.99. How many lawns will she need? So okay, so once you get the rules, it's easy to find out. You don't have to extend the table until you get $55. But she needs $55, so I come up with the equation and then plug in the number in the right place, and you'll be able to find it very easily. And the last one, you can make patterns of shape by connecting matchsticks. Stage 1 is 1 square. Okay, let's do that. 1, 2, 3, 4, right? And then you can obtain each consecutive stages by adding a square to the side of the previous stage. So you used 4 here, right? That's what it says right here. And then next one, you're going to put 1, 2, 3. So you need 3 more. That's why you have 7 right here. And then stage 3, you're going to add 1 more here. So what will be this number, right? And then stage 4, stage 5, and then at the end, so complete the table first, and then write the recursive rule that describes these patterns. The recursive rules, one more time, is the pattern between consecutive output like that, right? And also, yeah, so that's it.